Welcome to Geology Simply Explained. The purpose of this video series is to provide very simple explanations of very complicated geological processes that form mineral deposits. In this one, we're going to discuss sedimentary exhalative base metal deposits, otherwise known as SEDEX deposits. SEDEX deposits occur as the result of the venting of a mineral-rich brine into sea basins. This type of deposition occurred in ancient sea basins up to 2 billion years ago and are still occurring to this day. This venting is a result of extension faulting in the rocks that make up the sea floor. Extension faulting is caused by magmatic vortices in the Earth's liquid outer core, putting an enormous amount of stress on the rock that make up the Earth's crust, causing it to separate. Let's zoom in closer to the Earth's crust located below a sea where this extension faulting is taking place. The separation of Earth's crust causes a depression to form in the seabed called a graben. The extension faulting provides an escape route for the heat of Earth's interior. This heat causes venting to establish along the fault. Imagine the force similar to a jet engine thrusting a plume of water into a sea basin about 2 to 4 kilometers below the surface. This venting causes seawater to be drawn through the surrounding muds as it makes its way toward the intake of the vent. Along the way, this water dissolves minerals within these muds, becoming a mineral-rich brine. The metals dissolved within this brine are largely iron, but also lead, zinc, and silver, and other minerals such as sulfur. This mineral-rich brine is ejected by the vent into the surrounding seawater. The brine chemically reacts with the seawater, causing the dissolved minerals to precipitate out of the solution and settle to the sea floor. The graben, caused by the extension faulting that gave rise to the venting in the first place, now acts as a depression for some of these metals to accumulate. This occurs over a long period of time, perhaps hundreds of thousands of years during a relatively quiet period of tectonic activity in the region. When this quiet period ends, marked by an increase in earthquakes due to tectonic activity, large amounts of sediment enter the basin, blanketing the sea floor, causing the venting to cease. An example of SEDEX mineralization is the 1.34 billion year old Sullivan deposit. It formed in an ancient sea basin known as the Aldridge, which today is located in the East Kootenay region of British Columbia. Here, sediments shedding into the sea basin eventually build up 13 kilometers of rock over the deposit. Uplifting, due to continental collisions, eventually moved these basin rocks upward, exposing them to the forces of erosion. After hundreds of millions of years, this rock is eroded away to the point of now cutting into this long-buried SEDEX deposit. In 1896, prospectors discovered the exposed Sullivan mineralization. It took many years and much work to realize the extent of this deposit, which ultimately became the main asset of a company called Cominco for much of the 20th century. In most areas where SEDEX deposits occur, they are often found in clusters. This is due to the vents migrating along these extension faults as the hotspot deep below also migrates. In the case of the Aldridge Basin, only one deposit was ever found, the Sullivan, a behemoth being one of the largest of its kind. It contained well over $40 billion of metal based on recent prices. The search goes on for others of its kind. We hope you enjoyed this video and that it helps you to understand the processes that form SEDEX-based metal deposits. Thanks for watching.